Okay, so I talked about this in the last video, about this rabbit situation, and we drew the free body diagram, and I had mentioned how the normal force looks like it's greater, and it looks like it should be accelerating upwards, but let me kind of just break this down. I want to break this down into your X and Y components, your horizontal and vertical, I guess you could say. Let's start off with your Y components, your up and down. I'm just going to draw a separate free body diagram for this. So let's look at your up and down. I've got dotted line, got the dot. So, okay, so you know your weight is pulling this rabbit down. So I'm going to write mg. Now, what I'm going to do is kind of an unconventional way to do this, but I'm fine if you do your free body diagram this way as well. If you look, you've got, remember I just kind of took this from up here and put it here, you have something else pushing this thing into the ground. It is this. It's your force of your bunny. All right. Sine theta. Okay, and so that means, I guess I'm going to delete my Y up here. This is Y. Y is done in green. Let me delete this real quick. All right. So this means that your normal force, since your acceleration in your Y direction, it's a little bit darker green. Oh well, your acceleration in your Y direction was 0. That means these two forces are going to have to balance each other out. So this one is roughly the same size as your normal force. So this means that the surface is having to push up 90 degrees more on the cart because the bunny's pushing down on the way to the cart, making it press into the floor more. So this is how you would do this. I'm going to go ahead and delete some of this over here. So the way that you would handle this using Newton's second law is pretty straightforward. Okay, sorry. It's like this. So I'm going to take all of this green stuff and I'm going to come over here to work on it. Okay, so I would write acceleration, equals 0. And I'm also going to write net force equals mass times acceleration, therefore net force equals 0. So if you really just wanted to kind of put this together, you could take, because you know your net force also equals your big force, or your force that causes the acceleration minus your little force. You can look at it that way if you want to look at it mathematically, but let's just look at this practically. This isn't accelerating, so these two added together have to equal this. So you could just say this, and it would be the magnitude of, technically, because one was going up and one's going down. So you could say the magnitude of your normal force is equal to weight plus FB, force of the bunny, sine theta. And basically, if you were just to see this written down, what this says is something is pushing this object into the ground in addition to its weight, and that's how much the ground's having to push back up on it. This would be good if you had to design a stage or a table or chair that had to hold a certain amount. Just something to kind of consider on that. So these are your Y components. So this would be how you could find your normal force.